All right, in this video, we're going to look at problem 1, which says compute the divergence and curl of the vector field f, which is x squared yi minus 2xy squared zj plus the quantity x plus y minus zk. All right, so to start with the divergence, as we saw in the last video, this is the dot product of the del operator with the vector field f, and we'll also write this as div f. Okay, so these notations are interchangeable. Okay, and what we saw is that the outcome here of this dot product is the sum of these partial derivatives. So we take the x derivative of p, which is the I component of the vector field f, and the y derivative of q, which is the j component, and then the z derivative of r, which is the k component, and then we sum those derivatives together. All right, so let's do that. So the x derivative of p here would be 2xy. The y derivative of q is minus 4xyz, and then the z derivative of r is negative 1. All right, so that is the divergence. Okay, not too bad. And note here that the divergence of a vector field f is a scalar field, right? This resulting expression is a scalar function of 3 variables. Cool. All right, so now let's do the curl. So here we're taking the cross product of the del operator with the vector field f, and we'll also write the curl as curl f, so these are interchangeable notations. And as you know from Calc 3, cross product can be computed in terms of a 3 by 3 determinant, right? This is where we lay out the basis vectors in the first row, so I, j, k. In the second row, we have the components of the del operator, and then in the third row, we have the component functions of the vector field f. All right, the other thing you have to keep in mind is that when you expand determinants, okay, you're not applying traditional multiplication, right? These differential operators, right, are taking derivatives. So let's check it out. For the I component of the curl, I'm going to delete out column 1 and row 1, and then I'm going to take the determinant of this resulting 2 by 2 matrix here. So I'm going to take the y derivative of this expression, which is 1, and then I'm going to subtract from that the z derivative of this expression. And this is minus 2xy squared for the derivative. I'm careful there with the signs. I'm subtracting a minus 2xy squared. Okay. Now for the j component, remember there's an alternation of sign for 3 by 3 determinant. And so in front of the j component, I'm going to put a minus sign here. And now I'm going to go ahead and take the determinant of the 2 by 2 matrix that results from deleting column 2 and row 1. So I'm going to take the x derivative of this expression, which is 1, and then I'm going to subtract from that the z derivative of this expression. And this is independent of z, so this has a derivative of 0. All right, and then for the k component of the curl, okay, I'm going to take the determinant of the 2 by 2 matrix that results from deleting out row 1, column 3. So I'm taking the determinant of this 2 by 2 matrix. So I'm going to do the x derivative of this expression. So that's minus 2y squared z. And then I'm going to take subtract from that the y derivative of this. So I'm going to be subtracting x squared. There we go. Cool. All right, and then I'll clean up a bit. And then we have 1 plus 2xy squared, and then negative 1, and then minus 2y squared z minus x squared. And that is the curl. Okay, and we note here that when you take the curl of a vector field, f, you get in return another vector field. All right, well, that's going to do it. Thanks so much.